Hello everybody, welcome back. Today we'll be reviewing K56 question K56b question 1, and it says given that f of x is equal to x minus 5 squared plus 3, and then our boundaries are located from a to a plus 2, we need to find the maximum value. So if you want to take a good look, this question is actually the exact same equation or question as the last video I did, except that instead of asking for the minimum value, they are asking for the maximum value. So that's going to change things up a little bit. So before we start, I'd like us to take a look at it visually. So go ahead and take a look at this graph that I drew. So let's say I'm just going to put my two boundaries, a and a plus 2, on two random places. Let's call this a and a plus 2. So we're looking at the regions in between the two yellow dots, and also including the yellow dots, so like I drew here. In this case, we know that the maximum is f of a, right? That's the highest point. That should be pretty obvious. And then let's just locate the two boundaries a little more to the right. Let's say a is over here and a plus 2 is over here. So a plus 2 is actually crossing or to the right hand side of the vertex now, but we can still say that the maximum value is at f of a in this case still, because f of a is still higher. So it's not the minimum value, whereas the minimum value, if they were asking for us for the minimum value is at the vertex. In this question, the vertex isn't really like an important, I guess, part of the question. So as long as so when does the, let's say, maximum value is no longer at f of a? Well, that is when f of a and f of a plus 2 are equal. In that case, we can no longer generalize the maximum value to just be specifically at f of a. It can be at f of a plus 2 as well. So we need to find out what a value makes these two things, these two like boundary, the left hand side and the right hand side of our boundary, equal. So the y values from plugging in a and a plus 2 are exactly equal. So to find that, to generalize what I just said into like I guess an equation, that's saying f of a plus 2, make that a little bit smaller, f of a plus 2 is equal to f of a. So what value is the right hand side of the boundary equal to the left hand side of the boundary? So I'm going to go ahead and plug in a plus 2 into here, and then just doing some algebra, I would get a plus 2 minus 5 squared plus 3 is equal to, plug in a into x here, I would get a minus 5 squared plus 3, and then if I wanted to simplify, this would be a minus 3 squared plus 3 is equal to a squared minus 10a plus 25 plus 3. And then this left hand side, a minus 3 squared is just a squared minus 6a plus 9 plus 3 is equal to a squared minus 10a plus 28. If I subtract a squared on both sides, the a squareds will cancel out. And then if I subtract or add 10a on both sides, I will get 4a plus 12 is equal to 28. 4a is equal to 16. A is equal to 4. So a equals 4 is the exact point at which plugging in the two ends of your boundaries will give you the exact same y value. So that's very important to keep in mind. So I'll go ahead and erase this, but just keep note of how we got a equals 4, because that is a very important a value. So we know that as long as a, for the first scenario, you can say as long as a is less than 4, then the maximum is always going to be at f of a, which we got to be, if we just go back a couple steps and find out what I got from plugging in f of a, I'll just do it for the sake of time would be a squared minus 10a plus 28. And that kind of makes sense because if we plug in like 3.5 into our into our interval, we would get 3.5 is less than or equal to x, which is less than or equal to 5.5. As you can see, the vertex as you can see 3.5 is actually 1.5 units away from 5, which is x equals 5, which is at the vertex, and 5.5 is only 0.5 units away, meaning 3.5 is going to be higher since it's farther away than from the vertex than 5.5. So that's the first, I guess, inequality. And the second inequality that we get a different maximum value, as we saw, was when f of a was equal to a plus 2. Sorry, f of a was equal to f of a plus 2. And that was when a was equal to 4. That's the special value of a that we got. So as long as a is equal to 4, we can say the maximum is at f of 4, which is also equal to f of 6. Because if I plugged in a equals 4 into here, I would get 4 is less than or equal to x, which is less than or equal to 6. And that kind of makes sense because if your intervals are from 4 to 6, each boundary is just 1 unit away from the vertex, which means they will have the same y value, since the vertex is the point at which the x value of the vertex is the axis of symmetry, meaning if you go from right and to the left of the vertex the same amount of units, you'll end up at the same y value. So if you wanted to plug in that into one of these x values, you should get the same thing if you plug it into the original function. If I plug in x equals 4, I will get 4 minus 5 squared, which is just 1, plus 3, which is 4. So that's going to be the maximum. And then our third scenario, we can say that as long as a is greater than 4, the maximum is then going to be, so as long as this is, if you refer back to this is when a is equal to 4. These two ends of the boundaries or interval are the exact same. But let's say let's say a is greater than 4 now. So let's say a is over here and a plus 2 is over here. As you can clearly see, f of a plus 2 is now higher than f of a. So that's going to be defined as our maximum. So our maximum is going to be f of a plus 2. And if to save some time, if you want to refer back to what I did at the start when we were solving for what value of a gave us the, so when the, now what values of a was it so that the two ends of the interval were equal? This would be equal to a squared minus 6a plus 12. And this kind of makes sense because think about if a, let's say, was 4.5. If a was 4.5, then your end of your boundaries would be from 4.5 to 6.5. And 4.5 is only 0.5 units away from your vertex. And then 6.5 is actually 1.5 units away from the vertex, meaning since 6.5 is more units away from the vertex than 4.5, that means that right hand side of your boundary is going to be the maximum. And in this specific scenario, when a was equal to 4.5, f of 6.5 is going to be your maximum. And yeah, that's it for that one. So you have 3 different answers at which you all have different maximum values. Yeah, that's it. All right, take care. Good luck.